Hello everyone. In this video we draw the Turing machine for the 2's complement. So let's suppose we assume one example like 1 0 1 1 0 0 0. So this is the input string. Now we first find out the 1's complement. So what is the 1's complement? This 1 converted into 0, 0 converted into 1, 1 converted into 0, 1 converted into 0, and this 0 converted into 1, all the opposite. If here 1 is present, then converted into 0. If 0 is present, converted into 1, vice versa. This is the 1's complement. And if you want to find out 2's complement, then add 1 here. Plus 1, add 1 in 1's complement. So that time what we do, this 1 plus 1 0 carry 1, then this 1 plus 1 0 carry 1, this plus 1 plus 1 0 carry 1, this 0 plus 1 1, then this 0, then this 1 as it is, and 0 as it is, this 0 as it is. So I hope all you get idea how we find out the 2's complement. First find out the 1 complement, which is nothing but the vice versa of the symbols. If 0 is present, converted into the 1, and if 1 is present, converted into the 0. Now add 1 in the 1's complement. So 1 plus 1 0 carry 1, 1 plus 1 0 carry 1, then 0 plus 1 1 is 0, 1 and 0. This is the 2's complement. Now think about this input string and this output string. These are the two. This is the input string and this is the 2's complement, output string. If you observe carefully, then here is the 0, here is also 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 0. If 3 zeros are present in the right side, we travel now in the right side. If the zeros are continuously present in the right side, kept these zeros as it is into the output. Once you reach to the 1, then kept this 1 as it is here, this one and this one. After all the zeros, when you reach to the 1, kept this 1 as it is here, and after this 1 change all the symbols. Means if here in the input 1 is present, then convert this into the 0 in the output. If here 0 is present, then change this 0 to the 1. So here we see this 0 converted into 1. Now this is the 1, then output is 0. So I hope all you get the logic about the 2's complement. First, here is the null, here is also null. So we start with this null value. So we start with this null value. We travel one by one at the right side. That time we kept all the symbols as it is. This 1 kept as it is, 0 kept as it is, 1 kept as it is. So in this way we move to all the symbols in the right. Then after the reaching last symbol, we move to the right and we read null value. When you read the null value, then travel at the left side now. And after the left side, if you read this 0, then kept this 0 as it is, move to the left. Then again you read the 0, kept 0 as it is, move to the left, kept 0 as it is, move to the left. When you read the 1, then kept this 1 as it is and move to the left. Now when you read the 1, then change this 1 into 0. If you read 0, change this 0 to the 1. Now again move to the left. This 1 change into the 0, and after you at the end you read the null, and when you read the null means you are in the final state. So this is the logic. Now same logic we draw here in the Turing machine. So let's start. So we draw the Turing machine. So at the initial state, Q0 state, we take and we read null. So kept null as it is and move to the right. If you write this state, then it is also okay, and if you not write, then it is also okay. But the good practice is we start reading the Turing machine with the null value, then that's why I write here. And if you not write this state, then it is also okay. Now Q1 state. Now real logic is start from this state, Q1 state. Here in the Q1 state, we first read all the symbols one by one, but kept all the symbols as it is and move to the right side. So here in this state, so if you read after the null, if you read any symbol, means if you read 1, kept 1 as it is, move to the right. If you read 0, kept 0 as it is, move to the right, and you reach to the null after traveling all the symbols. Then you read null, so kept null as it is, and now start to travel in the left side. So we now travel in the left side. In the left side, this is the Q2 state. Now here, if you after the null value, if you read zeros, then kept the zeros as it is. If you read 0, kept 0 as it is and move to the left and cover all the zeros after the nulls and kept all the zeros as it is. And when you finish all the zeros, you read 1, and if you read 1, then kept 1 as it is, first one, and move to the left. And after this 1, when you kept as it is, and after all the symbols you read, change all the symbols vice versa, means in this Q3 state. Now here, if you read 1, then change this 1 to the 0 and move to the left, and if you read 0, then change this 0 to the 1, move to the left and cover all the symbols. And after finishing this, when you read the null value, kept null value as it is and move to the left or the right, it is okay, and you are in the final state, Q4 state or the halt state. What you want to give the name, give. And this is the Turing machine for the 2's complement. Now we take one example for the simple understanding. So this is the example we consider 0 1 1 0. So starting with null, end with null. So at the starting, we are in Q0 state and we read null. When you read the null, reach to the Q1 state, Q1, and move to the right side. So 0, we are here, right side. Then 1 1 0, null. In Q1 state, now any symbol you read, then kept this symbol as it is and move to the right. So all the symbols we cover one by one, and we are in the same state, Q1 state. So null 0 1 1 0 null. Then again Q1 state, null 0 1 1. Now we are here, 0 null. Now Q1, null 0 1 1 0 null. Now again kept as it is, Q1, null 0 1 1 0 null. Now we read null. When you read the null in Q1 state, go to the Q2 state, but start to travel in the left side. So in Q2 state, null 0 1 1 0 null, kept null as it is null and move to the left. Now we read 0. In Q2 state, if you read 0, kept 0 as it is and move to the left. So Q2 state, now where we are, Q2 state itself. So 0 1 1, this 0 kept as it is and move to the left, and a null. In Q2 state, if you read 1, then kept 1 as it is and move to the left, and we are in Q3 state. Q3 state, null, 0, 1, 1, and now we are here left side, and 0, 1, null. Now in Q3 state, if you read 1, then change this 1 to the 0 and move to the left. Change this 1 to the 0 and move to the left, means here. This null, 1, 0, null. And now we are in Q3 state itself. Now again in Q3 state, if you read 0, then change this 0 to the 1 and move to the left. So Q3 state, move to the left and convert this 0 into 1. 0, 1, 0, null. Now in Q3 state, if you read null value, then move to the Q4, which is the final state, and now this string is accepted. So Q4 state, and this null kept as it is, and 1, 0, 1, 0, null. So this is the final state, and we accept this string. Now we cross check this is correct or not. So what is the input? 0, 1, 1, 0. So we take here 0, 1, 1, 0. So first we find out the 1's complement. So 1's complement is 1, 0, 0, 1. Now we add 1 for find out the 2's complement. So 1, 1, 0, carry 1. 0, 1, 1. This 0 kept as it is, 1 kept as it is. So this is the 2's complement, and same here the output we get. This is, and this is the same. So I hope now you get the idea about the 2's complement, how we prove this example, and how we draw the Turing machine. Now if any doubt or any query, then let me know in the comment box. Thank you.